Now let's go for the second NF. Now second NF is all about partial functional dependency, as we have discussed in the last class. Partial functional dependency means if the part of the key is determining some non-key, that particular functional dependency is called partial functional dependency. And in the second NF, we don't want these type of functional dependency. So we don't. So what is the definition for the second NF or second normal form? That a relation should be in a second normal form if and only if it is in first normal form, as well as there is no partial functional dependency. It means that every non-key attribute is fully dependent on each candidate key. Means it should be a full functional dependency, not partial functional dependency. So about that, we have seen this example. Let's start today's class with this example only. So here we have the example in which we have the relation given and the attribute given. Okay. So you assume that we have a relation like this, and we are just putting it into, and we are abbreviating this as A, B, C, D, and E. So let's say we have a relation in which we have the attribute A, B, C, D, and E, right? A, B, C, D, and E. And we have set of functional dependency. So this will depict as, so this is A and B determine C and D, right? A, B determine C, D, right? So I am abbreviating that invoice number as A, line number as B. So I'll put it like this. This is A, this is B, this is C, this is D, and this is E. So the first functional dependency will look like this. AB determines CD. The second functional dependency, which is AC, determines BD. And the last one is A determine E. Right? If this is the functional dependency given, so can we say that it is in a second normal form? So in the second normal form, we have to see that all the functional dependency there should not be any partial functional dependency. So for that, we have to find the key. Now, how I'll find out the key? I'll find out the closure. Let's say we'll find out the closure of AB first, because this is the first functional dependency we have. So the closure of AB will come. Now A is determining something. Yes, A is determining E. A, B together determining something. Yes, they are determining C and D. So as you can see, this is equal to R. So I can say that AB are candidate key. Let's go for AC closure. AC closure is AC. A is determining E. AC together determining B and D. This is also equal to R. So I can say that AC is also a candidate key. Let's go for the last one, that is A. So A closure is nothing but A. A is determining E. E will come. AE is determining anything? No. E also not determining anything. So A will be there. It is not equal to R. So what is my candidate key? Candidate key are nothing but the list of attribute or list of minimal attribute which can become the primary key. So we have AB as the candidate key and AC as the candidate key. Now, before designing the database, I have to choose any one of the candidate key as the primary key. Let's say I'll choose primary key. I'll choose primary key as the first one, which is AB. Primary key as AB. Okay. Now, if I am choosing primary key as AB, so what is my functional dependency? Again, writing here. So I have a relation with how many attribute? 5 attribute. What are the functional dependency? The first functional dependency is AB determine CD. Second one is AC determine BD. And the last one is A determine E. Now, if I'll choose AB as the AB is the primary key. So AB is determining something, it is okay. AC is determining something. Can we say that part of the key is determining some non-key? Now here if you'll see this particular functional dependency, if AB is the key, this particular functional dependency is not fulfilling the requirement of partial functional dependency. Partial functional dependency says that part of the key is determining some non-key. Here we have the part of the key, right? Along with that, we have what? Non-key. C is a non-key, right? AB is the key. And it is determining what it is determining. It is determining key plus non-key. What we want that part of the key is determining some non-key. If this is the case, I say that it is a partial functional dependency, right? But is this the case in the second, no, second functional dependency? No. So in the second functional dependency, it is a part of the key. It is a non-key. It is a key, part of the key plus non-key. But I need part of the key is determining some non-key. Now go to the last one. Last one is A. A is a part of the key because key is AB and E is a non-key. So part of the key is determining some non-key means it is a partial functional dependency, right? If this is a partial functional dependency, then what we have to do? What we have to do here? We find out that partial functional dependency exists into the functional dependency which is there, and which functional dependency is creating the problem to become this particular relation into second NF. So we have this is a relation, and we have functional dependency AB determines CD, AC determine BD, and A determine E, in which we find out this is creating problem. A determine E, the last one is creating problem to become this particular relation into the second normal form. So what we do is we split the table into two table, R1 and R2. In R2 table, we'll put those attribute which is creating problem. So which is creating problem? AE is creating problem. So I'll put AE into one table, one relation. So it is coming into one relation. And in another relation, we have all the other attribute. So we have A, we have B, we have C, we have D. A will be here. Why I'm putting A here? Because we have A here. It doesn't mean that we have to put A here, but we are putting here because there is a simple reason that if we are dividing or splitting two tables, it should be splitted in the base of some common attribute. So what is a common attribute here? So A is the attribute here. Here we'll put A. Why we are putting here A? Because A is the part of the key. If we'll remove A, then there will be a problem for finding out the key. As well as I told you in the last class that in the second normal form or up to the second normal form, we can say that the functional dependency preserved. So here if you'll see R1 preserve the functional dependency 1, this one, as well as functional dependency 2, this one, and R2 preserve functional dependency 3. Getting it? So R1 preserving functional dependency 1, R2 preserving functional dependency 3. So R1 is preserving two functional dependency and R2 is preserving one functional dependency. So it means that all the functional dependency is preserved after splitting the table. So dependency will be preserved up to second normal form. So in that way also you can see that how we can split two tables. Okay, this is also a way how we can find out to split the two tables.